In today's problem, we are going to discuss about the isometric projection of this object. The overall length of this is 25, 20, 25. That would be 70 total. And the height would be 6, 7, 12. That should be total 25 height. And here you can see the width is total 40. So out of this data, we are going to create our isometric projection. This is the front view. And this is the top view. This is front and this is the top view. Over here in the first angle of projection. For creating one isometric axis, that is 120 degrees of each, you are going to make 30 degrees out of this one first. Next 30 degrees. And next your height axis. This would be height, and because we are taking this as a front view, both the side views would be same. So we can take the front view in this direction or in this direction, no matters. So I'll take the front view in this direction. This would be your front view observer, and this would be your side view observer, and the side view which we are taking here is in this direction will go the right side, and that falls over here for the first angle of projection. This would be right side view. Okay, and this would be the height, and this would be the length, and this would be the width. Coming to this figure, this overall is length, this is height, and this is width. So we'll be covering our length, width and height axis on this isometric axis. These are isometric axes, and the line followed parallel to these are called isometric lines. So first of all, we'll finish with the front view. The height from over here is 6 mm from this. Later that 7 mm. Later that it would be 21. So total the height equals to 6 plus 7 plus 21. So this is 6, 7 and 21. Total height of this would be this much. And coming to the length, we have first step 25. So I'll be taking 25 on this. So total I'll calculate with this. Total is 70. From here 25 and 10, 20 and 25. This is the total length. 25, and from here the length would be 15, as you can see over here, this one, 15, 15, 15. The same I'll repeat over here. Now I can draw the height lines, 6 mm and 7 mm over here. So I'll keep my draft scale parallel to the height axis, so I can draw all the height lines. This is the first line, height line we are going to follow. The second one over here, third, fourth. Here you can see the bottom portion of this is ready. Then we'll go with the height of 21 from this point. This is the height. Next we'll follow with this length, small length, and the length of the this line can be seen here. The projector over carries here, and this projector length 8 mm. We have finished with that. Next we have to find the location of this one, where it is in the figure. So you can see from the bottom base, means this one, the height from here, this one to this one is 6 plus, I think this is not given here, so we can calculate from the top. From the top it is 12 and 5. 12 plus 5, 17. So 21 minus 17 would be 4, right? So 12, 5, 17 plus 4, 21. But from here we have a height of this 17 from top. So from top we have to calculate 17. So from top we have to get this. From here I am taking 17, a dot, small reference line over here, and we have to measure this also. You can see that is 8 mm width, and that would be the center of the figure. Means from here or else from here 20, 20 minus 8 would be 12, 12 by 2, 6. So from here it is 6 mm, from here it is 6 mm. From here it is 6 mm. Here you can see the point. From here it would be 8 mm. So I'll elongate this with the little height 5 mm. This is 8 mm. Again parallel to the height. This 5 mm. Now you can join this lines as you can see here. So we have finished with the front view of this figure. Now you can simply draw this width line from this all points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all these points you can join the width lines a length of 40 mm. That's all. So front view is finished. We are going to reference with the front view. Now I'm keeping my drafter parallel to the width axis so I can draw all this width lines. The length of the dimension of width is 40 mm as given in the figure. So I'll simply draw the 40 mm line from each and every corner. That's all. For this problem, this corner, I can't draw the straight line because the straight line, the width line is under this surface. Under this surface, so I can't draw this line. So I have to go for again this one. And for this line also I can't draw the full length of 40, full dimension of 40 from here because that would be under of this one. So we have finished with the width lines. Then we'll cover this with the height and length lines. The length lines are parallel to this and height lines are parallel to this. Finish with the problem. Then we have to give the dimensions for this, and we are using align dimension technique. I'm maintaining a 10 mm gap of between this axis, isometric axis and the dimension line. For every figure we have to maintain the same. Whatever the diagram you are drawing, you have to maintain the dimension line gap of 10 mm from the figure. Anyhow, we have to draw the dimension line outside of the figure, but for some objects, some places, we have to take the dimensions inside of the figure, like this one. Arrays of extra lines, extra dimension lines. And you have to draw the arrow marks 1:3 size, arrows 1:3, and this would be dark. This would be 3, and this would be 1. And you have to maintain the all arrow size as possible as same. This is 40, 25, 20, 25, 6, 7, 21, 5, 12. And for this width, I'm showing the dimensions over here. 8, 8. This is 15. This is the isometric projection of this object. So just have a look. This object, this over here, the isometric projection of this figure.